Hello friends, very good afternoon. I welcome you all to my YouTube channel and myself Dr. M.H. Annaya. Friends, in today's video, we have got a problem on the section of a cylinder wherein we are given with only the height of the cylinder. The diameter of the object is not given and we are required to draw the front view, sectional side view and sectional top view of the cylinder, and also draw the what is called development of the lateral surface. Is a nice problem which combines the section of the cylinder along with the development of the lateral surface. In fact, we are learning two solution for two problems in the same question. Friends, the cylinder is a circular object which has got its dimension same throughout its height. And it says in the question that a cylinder of height 80 mm, which I have shown here, is cut by a section plane such that the true shape of the section is an ellipse having major dia 60 and minor dia 40. 60, other is 40 mm. You can say minor dia is 40 millimeter. Friends, whenever you are just cutting the cylinder by a horizontal section plane, it's very obvious. You are going to get the sectional top view, a circle with hatching done throughout. And if it is cut at an angle, the dimension of the cylinder which is perpendicular to the board, that is to say this dimension, which is nothing but the diameter of the circle, whether it is at an angle of 40 degree, 30 degree, or it is passing through the extreme ends of the top and bottom face. In all these cases, you observe that the dimension perpendicular to the board, that is the dimension CG, is going to be the diameter. Or in other words, we have this ellipse having 60 mm dia. So when you are taking the true shape, you are going to hold a mirror parallel to the section plane SS at a convenient distance. And this distance has to be 60 mm. And the other dimension, which is perpendicular to the board, is the dimension CG, which is equal to 40 mm. So in the true shape, you are going to get the major diameter is going to be 60 and the minor diameter is going to be 40 millimeter. So only if we know this concept, we will be able to work out this problem and not otherwise. Because without knowing the diameter, we can never construct a cylinder. The height is given, but diameter should be known. So based on this concept that the true shape of this is going to be an ellipse, we have drawn this dimension taking this diameter equal to 40 mm. That is the diameter of the cylinder. Now friends, as you know, this cylinder, it doesn't have any of these edges. So we divide the periphery of the top view into some 8 number of equal parts minimum. That is, we are drawing a vertical line, a horizontal line, and again lines at 45 degrees to the horizontal. You are going to get this circle divided into 8 equal parts. So we will name this divisions as A, B, C, D, E, F, G and H. So this is the top view. And since it is a cylinder, like our prism, we should make double marking. So it's going to be A comma A1, BB1, CC1, DD1, EE1, EFF1, GG1 and finally HH1. This is O comma O1. O is the center of the top face, O1 is the center of the bottom face. So we'll have this as O dash and this is O1 dash. Friends, remember, marking is also equally important in the projection or development of any solid. Friends, now I've taken the height, constructed the front view of this. And this section plane, how I have drawn this, exactly at the center of the height. Excuse. I have taken up the center of the axis, and from there I am going to draw two arcs, each of radius 30 mm, because the major diameter is 60. I have taken 30 here, drawn an arc, again 30 here, I have drawn an arc. And this is how I locate the position of the section plane. If it is 70, you take 35 here, 35 here along this. Friends, the bottom portion of the solid is retained, and whatever you see here is going to be our front view. And before that, let me transfer these points. That is A dash, B dash, H dash, C dash, G dash, D F, and E dash, D dash, F dash. Last is E. Similarly, E1 dash, and this is going to be A1 dash, etc. There is no place to mark, so you will be able to obtain what these points are. Friends, now after this section plane is cutting the solid, the bottom portion which I have shown in dark lines is retained, and the portion above that is thrown out. So only for this portion we are going to have this as the front view. And friends, now after the solid is being cut, you can just observe here the generators AA, BBH, CCGG, DDFF, and this is E. All the 8 generators of the cylinder are cut by the section plane. So if it is AA, you are going to have a point here 1. This is point number 2, 3, 4, 5. I'll just mark it as 5, 6. This is 7. This is 3. I have marked here 3. This is point 8. There's no place, so I'm not marking. So this figure will give you the front view, and this will give you the top view. Since this portion is removed, we have to hatch the complete top view of the object. So by drawing lines at an angle of 45 degrees to the horizontal, I have hatched this or sectioned this. And friends, this figure will give you sectional top view, STV. That's asking the question. Draw the front view, sectional top view, and friends, we need to draw the sectional side view of the object. So after you throw this portion, in the end you will be able to see. So before that, let me get the side view for a cylinder. The front view and side view will be exactly identical when it is placed on HP with the axis normal to HP. So friends, let us see what are the points. This point is going to be G dash, and this other extreme is C dash. You got A dash and E dash in the center, A dash, E dash. Again 1 1. So since it is side view, we have to make it as double prime out of G double dash, A double dash, etc. And friends, similarly for the bottom face, you have got G1 double dash, this is A1 double dash, this is C1 double dash, this is G, last is C, you can see. Friends, let us obtain the points one by one. The section plane cuts generator GAA at this point. So from there I am going to write a line till it touches the AA and EE. So this is an AA. This is on AA, you're getting a point. And then this is on BB and HH. Where are BB and HH? This is B double dash, H double dash. So on AA it is cut here. I have marked at this point. AA, BB and HH are cut at this point. So you have to mark BB here and HH. This is B and D. This is B double dash, D double dash. This point is going to be H dash F. H. F. So H double dash, F double dash. Yes. G, H, F. Then AE, you're right. Then you have got BD. BD is correct. The last one is C, C double dash. Friends, we have marked for these two. That is BBHH. HH is here, BB is here. You have got 2 points, friends. Similarly, The generators CC and GG are cut here exactly at the mid height. So that one is on GG, other is on CC. Am I right? Yeah, GG and CC. Next, friends, similar to this, you are going to have points on the other side exactly identical. This is on DD and FF. So we will mark it here DD and FF. This is DD and this point is FF. Finally, friends, we have got on EE a point on EE. So you can write a horizontal line from there and mark on EE. Friends, you have got 8 points where the section plane is cutting all the 8 generators, and whatever the points we get here, we have to join them by a smooth continuous curve. This is how, friends, you are going to get an ellipse in the end view. So we have to hatch it or section it by drawing lines at 45 degrees to the horizontal. Friends, the bottom portion is retained. So I am going to show that bottom portion of the retained part by dark lines. So this is how it will appear, friends. The base of the solid is intact, so I have to show like this. Friends, the portion above this is now removed, so we don't have anything above this. So friends, this will give you the left sectional end view, LSEV, left sectional end view or left sectional side view, or SSV, sectional side view you have got. Friends, you have got the front view, the sectional top view you have got, and we have found out that the diameter is 40 millimeter, and you have got the left sectional end view. What else is asked in the question? He is asking you to draw the true shape and also add the development. Friends, what we do to obtain the true shape of the section, friends, you know very well, to obtain the true shape, we have to hold a mirror parallel to the cutting plane or the section plane. And friends, let us say we have some space here, anywhere uh, above this object you can write. So I am going to write a line parallel to this, parallel to the section plane, that is, this is parallel to this, and we will transfer all these points, that is point number 1, 2, 3, 4, etc. onto this. So let me mark this point as 1. Say this is point 1. What I should do, I should write a perpendicular line to this two parallel lines. These are parallel to each other. So from every point where the object is being cut, we have to draw the perpendicular line. So this is one such line, and here on this we have got the other line. So exactly in the center you have got lines like this. So let me mark one by one. If I call this as point 1, the 1 is here. That is from the xy to this, you have to take and mark this as point 1. Suppose, say friends, this is point 1, and then you have got point 2 on this BB. Where is point 2? This is point 2, little away from there, but on this. So you should away from there. You should get the point. This point, then again on the other end, that is HH, you should have one more point. So we got 3 points, and similarly here, friends, you get what is called 2 more points here. That is going to be very obviously this value, that is 40. I will mark later on. Then friends, you have got 2 more points from this, and you are going to have these points marked here. Then finally other points. See friends, these points are the points on AA, BB, CC, DD, etc. So join all these points by a smooth continuous curve to obtain the true shape of the cylinder, which is going to be an ellipse. So this is how we mark this, and we can say this is the true shape of the object. I will say true shape. And they have given clearly in the question, it is an ellipse having major dia. Major dia is this one, and this distance is going to be 60 mm, very obviously, because this distance is this distance, which is 30 plus 30, 60. And here, friends, this distance is going to be distance from G to C, that is 40 millimeter. So the true shape you have got is an ellipse that is specified in the problem. So we have completed the true shape of the object. Finally, friends, we have been asked to draw the development of the lateral surface. So friends, what I do, I remove these lines, and now I am going to obtain the development of the lateral surface of the object. You know very well, friends, for any of these cylinders, the development is going to be a rectangle of width is equal to pi d, that is the circumference, and height is equal to 80, whatever the height they have given. So friends, I am going to extend this xy line here, and this height I will show here. And friends, you can draw a line here, and since none of the generators are completely removed, you have to have a rectangle here of width is equal to pi d. I will mark it here. This is the width, that is pi into 40. Pi d or 2 pi r, both are same. And this value you can calculate by multiplying 40 by pi. And height is equal to 80, the height of the object. Simply I will mark it here as 80, this height. Now this has to be divided into the same number of parts as that of the circle. So circle is divided into 8. So I am going to divide this also into 8. Now it is 2. Then again it will become 4. Again have 2 more lines in between, 2 more lines. So the circumference of the cylinder is divided into 8 equal parts. Let me name this as A, B, C, D, etc. This is A, B, C, D, E, F, G, H, and finally A, because the starting and the end point should be same. Similarly, for the bottom piece, you got A1, B1, this is C1, D1, this is E1, F1, G1, this is H1, and again this is A1. So drawing the development is very simple. We have the section plane. We know what is the part that is retained. This bottom part up to the section plane is a lateral surface, and that I have to show now. Let me start from this AA. AA is cut here. So I will draw a horizontal line from there to cut AA, this generator, and also this generator. So you will have one point on this. Then from here we are going to have points on BB and HH. So this is BB, and same height you are going to have HH. Then you have got CC and GG are cut here exactly at the mid height. So this is CG, CC, and then this is GG. Friends, we have got next DD and FF from this point. DD and FF is these points. Finally, friends, you have the section plane cutting EE at this height. So I will take that height EE at this height. Friends, you know, for all these cones and cylinders, the points so obtained are to be joined by a smooth continuous curve. So friends, I am going to draw a curve like this, passing through all these points. So the bottom portion is intact, and this up to this height you have to show only the outermost lines. So friends, this is intact. So we will show the base of the cylinder, bottom portion of the cylinder by this, and this is, friends, how the development of P, where P is the lower part of this. So this is the development of P, that is the development of the lateral surface of the lower part of the cylinder. Friends, accepting this curve and the border, you should not darken any of these, but you have to retain all the construction lines in the examination or in the test or whenever you do this drawing. So here friends, you can have these points marked as 1, 2, 3, 4, etc. before we conclude. This is 1, 2, 3, 4. Highest point is 5, 6, 7, 8, and this point is 1. So 1 is on AA, and then on B and H it is 2 and 8. This is 2 comma 8. CC and GG it is 3 and 7 at this point, 3 comma 7. Here you have got 4 comma 6 is this point, and last point is 5. And this is how we should mark. And by completing this development, we have completed the complete section of the cylinder and also the development of the cylinder. Friends, I hope and I am very confident that all of you have followed the procedure I have adopted to complete this problem. And friends, if you go through the problem and if you like my presentation in this video, please share the information with all your friends and have a nice day. I thank you very much for watching my YouTube video.